Hi, everyone. Thank you for coming today. I'm looking forward to chatting about plastic pollution and microplastics with you all. Thank you also to Lake Superior Living Labs Network for putting on this webinar and for having me. So what I'm going to talk about today is a bit of my own research and some of the research that's gone on in my lab at the University of Toronto, studying the fate and effects of plastic pollution in the Great Lakes. And I'm going to try to emphasize some research that has been done in Lake Superior specifically. So just before I get started on talking about plastic pollution, I want to take a step back and talk about the plastic itself. So plastic is synthesized using a chemical reaction called polymerization, where certain types of monomers are reacted together to produce a polymeric chain that makes up the plastic. Polyethylene, for example, is made up of monomers of ethylene that are reacted together to produce a polymeric chain called polyethylene. As a byproduct of this reaction, unreacted oligomers are produced. These are molecules that did not get fully reacted but are still present in the plastic itself and can migrate off the plastic, sometimes ending up in the environment and in biological tissues. Some monomers are thought to be more harmful than others. Polyethylene, for example, is what a lot of single-use plastic packaging is made of. And it's thought to be relatively biologically inert because the monomers are less biologically active. Polyvinyl chloride or polystyrene, on the other hand, are made up of more harmful monomers. Polystyrene is made up of styrenic compounds that are known endocrine disruptors. To produce a plastic product, pre-production pellets are melted down and chemicals are added to help the product achieve a desired characteristic. So for example, UV stabilizers are added to a product that is required to last a long time and not be broken down by the sun. You might have heard of the chemical additive called BPA, bisphenol A. This additive was used to create hard, clear plastics like in plastic water bottles, but was actually banned because of health concerns, including endocrine disruption. Once the plastic product reaches its end of use, it may end up as pollution in the environment. And in the environment, plastic acts kind of like a magnet, collecting contaminants from the surrounding water, like persistent organic pollutants and heavy metals, chemicals that are known to be persistent or bioaccumulative and toxic. In the environment, plastic products break up into smaller and smaller pieces called microplastics. And since plastics are made up of synthetic materials, they never truly disappear. And they also carry those chemicals that I have mentioned earlier and can pass those on to wildlife that ingests them. Microplastics can come in all shapes and sizes. So on the right hand of the screen here, you can see some plastic fragments that have broken off of larger plastic products, microbeads that were added to cosmetics like toothpaste, and pre-production pellets that end up in the environment because of spills. The picture on the left here is a water sample that was taken from the San Francisco Bay, and I use it to show the diversity of shapes and sizes and colors of microplastics. So there are some larger fragments at the top of the slide, at the top of the petri dish, and many, many smaller particles that are so small that you can't even see them without a microscope. Okay, so now I want to talk about some of the sources of plastic pollution, including both macro and microplastics. So one of the major sources of plastic pollution to the aquatic environment is runoff from urban centers. Runoff is the result of precipitation running over impervious surfaces into storm drains that lead directly into the aquatic environment. Runoff is one of the biggest sources of macro and microplastics to the aquatic environment. We also have effluent from wastewater treatment plants. This is the final product of wastewater treatment process. During the processing steps that occur at the treatment plant, solids are in both biological and anthropogenic solids are settled out and removed from the water. And then the water goes through various processing steps like chemical treatment, and they're also sieved to a certain pore size. But scientists that take environmental samples at outflow points of wastewater treatment plants have found extremely high levels of very small microplastics and microfibers coming from the effluent. And this is likely because the mesh used to sieve the effluent isn't small enough to capture these tiny, tiny particles. Application of sewage sludge to agricultural land is another process that's linked to the wastewater treatment plant. So during wastewater treatment plant processing, the solid material that's biological solid material that's removed from the water can be applied to agricultural land as fertilizer. And what ends up happening is that microplastics get ingrained in the biosolids and actually end up being applied directly to the terrestrial environment through agricultural lands. And then over time, the particles then eventually run off into rivers and lakes. And finally, aquaculture, fishing, and shipping industries. So, as you know, fishing industries and shipping are a big source of plastic pollution to the environment. So, if a large shipping container that contains a bunch of plastic products falls into the ocean, that can be a major source of plastic to the ocean. Fishing is another big source. So lost gear like fishing nets and fishing lines and ropes and buoys all might end up in the water for a longer period of time and end up as plastic pollution. Tire dust is another really big source of microplastic pollution to the environment. So tire dust occurs when the synthetic rubber particles that are on your tire break off the tire when you're driving because of the friction between the tire and the pavement. So there was a study that estimated that in the US, 600,000 tons of tire dust comes off of vehicles each year. And some of this dust gets ground into the road, but a large portion of it gets washed off into the ditches and then eventually into rivers and lakes over time and especially during rain events. Microfibers are another big source of plastic pollution to the environment. Microfibers come from synthetic clothing, so clothing that's made out of polyester, nylon, spandex, that kind of thing. They are released in huge quantities by washing machines. A study in our lab at U of T estimated that 200,000 fibers were released per load of laundry. And as I mentioned, wastewater treatment plants often cannot capture microplastics of that size. So the effluent tends to be a hotspot of fibers releasing to the environment just because of the insufficient filtration process. In our lab, we tested out two microfiber mitigation strategies, the Coraball, which is the image on top there, and the lint lever, which is the image on the bottom. These are both products that you can purchase online, and you add them to your washing machine to help capture some of the microfibers before they go to the wastewater treatment plant. The Coraball you add directly into your washing machine, and the lint lever is a filter that you actually hook on the outflow of your washing machine. So in our testing, we found that the Coraball decreases microfibers in the effluent by 26%, while the lint lever is 87% effective at capturing microfibers. So if the lint lever, for example, were applied on a much larger scale to lots of houses in a community, then you could have a very significant impact on the overall output of microfibers from the wastewater treatment plant into the aquatic environment. Okay, so now I want to talk about where the plastic ends up in the aquatic environment. And interestingly, the answer is different in the Great Lakes compared to the ocean. So you've probably all heard of the Great Pacific Garbage Patch, and when you think about it, you might picture something like the image on the left here, an island of trash that you could almost step out and walk over. But in reality, the Great Pacific Garbage Patch is actually a convergence of millions of tiny particles of plastic and fishing gear, not an island of trash, twice the size of Texas, like how it is portrayed in the media. Researchers have taken water samples from some Great Pacific Garbage Patch and have estimated that it is made up of 1.8 trillion pieces of plastic. There's an estimated 8 million tons of plastic entering the ocean each year, and a lot of the microplastics end up accumulating in these garbage patches. So this visualization here is a simulation to show where the particles end up over time. So in this computer simulation, they released virtual plastic pieces from different points throughout the ocean and showed where they would end up over time as a result of the patterns of ocean currents. So one thing you'll notice here is that there's not just one Great Pacific Garbage Patch, but there's actually multiple patches of microplastic convergence wherever the ocean currents converge. When plastic pollution first started being researched in the Great Lakes, scientists were worried about garbage patches accumulating in the Great Lakes. But computer modeling suggests that plastic pollution is more likely to accumulate on shorelines in the Great Lakes due to the smaller volume of the lake and strong winds. Lots of plastic is also expected to sink and accumulate in the sediment. In a way, this makes it easier for us to deal with because more plastic accumulates on shorelines rather than out in the middle of the lake. It's easier for us to reach and clean up. But it also means that beach sweeps and cleanups are impactful in the Great Lakes ecosystem. But it's also unsightly and could impact tourism and our enjoyment of beaches, also our freshwater resource for drinking water, and the fish and wildlife that inhabit the shorelines. A few studies have quantified microplastic pollution in the Great Lakes, although the Great Lakes ecosystem and freshwater as a whole is still really underrepresented in the literature of plastic pollution, which tends to favor marine ecosystems. Of the Great Lakes, Lake Superior is on the lower end of microplastic concentrations, and that's predominantly because of the lower population density and relatively lower industrialization compared to other of the Great Lakes. Um, and it's also a much larger body of water. The average concentration of microplastics across the Great Lakes is roughly 100,000 particles per kilometer squared, with a maximum of 1.2 million particles per kilometer squared found in Lake Erie. These concentrations are much higher than reported concentrations in the oceans, including the North Atlantic, which has a reported average concentration of around 8,000 particles per kilometer squared, and the South Pacific, which has around 27,000 particles per kilometer squared. The maximum concentration found in the Great Lakes even surpasses the maximum concentration from the North Pacific Garbage Patch, which is around 900,000 particles per kilometer squared. And one of the reasons that microplastic contamination in the Great Lakes can be higher than those in the oceans is because the Great Lakes are comparatively smaller and they are closer to urban centers, highways, and industries. Another study in our lab done by Keenan Munno reported on the concentration of microplastics in fish in Lake Ontario and Lake Superior. Here I'm showing just the data from Lake Superior, and you can see which species she looked at on the x-axis and the number of particles found in each fish on the y-axis. She found an average of 26 particles per fish with a maximum of 790 particles found in a single fish. In the Lake Ontario fish, there were twice as much microplastics on average, with a maximum of 900 particles in one fish. Again, this is higher than what is usually found in fish in the oceans, where there's an average of 0 to 5 particles per fish. And the vast majority of particles found in these fish was microfibers. So once an organism ingests microplastics, how do they cause harm? Well, microplastics are a very unique environmental contaminant because they pose both a physical and a chemical harm. The physical impact of microplastics includes lacerations and abrasions along the digestive tract, which can cause harm to the fish and can even cause fatality. Microplastics can also accumulate in the fish's stomach and cause the fish to feel full without providing any nutrients. In addition to the physical harm, microplastics also contain this cocktail of contaminants that includes additives, byproducts from manufacturing, and contaminants absorbed from the environment. This multidimensionality of microplastics makes them a unique pollutant, and it also makes it difficult to assess their true harm to wildlife. In recent years, researchers have come up with two leading theories about how microplastics cause harm. The first theory is maybe the most intuitive and most well researched. The idea is basically that if an individual's diet is made up of some proportion of non nutritious particles, the fish will obtain less nutrients and energy and will suffer consequences like decreased growth, decreased reproduction, and even mortality. And this is due to the physical presence of microplastics in the diet and the comparative lack of nutritious food particles. More recently, scientists have also begun to realize that the chemical dimension of microplastics also causes harm to fish. Microplastics can act as a vector for chemical additives and environmental contaminants into the tissue of fish, causing harm to the immune system and the endocrine system. And chemical disruption associated with microplastics can have a lot of complicated consequences for fish, including affecting their metabolism, their fertility, and even larval development. And so that's kind of where my research comes into this story of microplastic pollution. So, when I was developing the research program for my PhD research, I became really interested in this idea of the multidimensionality of microplastics. And I wanted to investigate the effects of microplastics, but I noticed that the convention for effects testing in the literature was to use microplastics that you purchased from a manufacturer. But when I thought about the life cycle of plastic products and what wildlife is actually exposed to, I realized that there was a huge mismatch between the plastic used for effects testing and the plastic that fish are actually interacting with in the environment. So when I developed my experiments, I decided to use two different types of plastic in two treatments. Some that I purchased from a manufacturer and some that I collected by hand from the shoreline of Lake Ontario. And you can see in the inset images here that I only chose to use black plastics to keep it very consistent, and I ground them down to the same size range, which was around 100 to 500 microns, and I chose to use two concentrations in my experiments. 100 particles per liter of water, which is relevant to what is found in the environment, and 2,000 particles per liter, which is a concentration that could be found in extreme hotspots. I exposed fish to microplastics for 6 months from their egg phase through to their reproductive phase. And then I raised a subset of their offspring in clean water for 5 days. And I wanted to answer three main questions. First, what are the long-term effects of microplastics to fish over their entire life cycle? Can microplastics have transgenerational impacts to the offspring of an exposed parental generation? And how do impacts compare between pre-consumer microplastics that I purchased from a manufacturer and microplastics that I collected from the environment? So in this experiment, I found that female fish exposed to microplastics that I collected from Lake Ontario had eggs that were more fragile and more prone to breaking. In this chart here, you can see the proportion of broken eggs in the environmentally relevant dose of Lake Ontario microplastics was much higher than in the other treatments. And to understand why the eggs were more fragile and more prone to breaking, I measured the thickness of the eggshells and found that the eggs in that same treatment had significantly thinner eggshells, as you can see in the top image, compared to the thicker eggshells in the controls. I also found that the fish in the same treatment had a much higher rate of developmental deformities. And my theory is that the thinner eggshells in that treatment allowed more of the contaminants to pass through and impact larval development. And these images show some of those examples of the deformities in the fish, which include edemas, which is fluid buildup, malformed eyes, and skeletal abnormalities. So in this treatment, the offspring of the parents exposed to Lake Ontario microplastics were less likely to hatch, and when they did hatch, they were more likely to have severe malformations. Looking back at my initial question, the difference between purchased and collected microplastics, I found that the microplastics that I collected from Lake Ontario were much more harmful to the fish than the microplastics I purchased from the manufacturer. The purchased microplastics did cause some disruptions to growth and stress that were suggestive of the physical or food dilution hypothesis. And the Lake Ontario plastics caused they caused the food dilution effects, but caused additional effects to reproduction and to offspring quality that were suggestive of the vector hypothesis. Ultimately, my research confirms how complicated microplastics are as a contaminant and shows that concentrations of microplastics that we are currently finding in aquatic ecosystems can actually be harming wildlife. Before I move on to the more solutions-based section of my talk, I briefly wanted to show you some of the ongoing work I'm associated with at the experimental lakes. So if you're not familiar with the experimental lakes area, it's a research station in northern Ontario that has 58 lakes set aside for research. In one of the lakes, we installed 9 in-lake mesocosm enclosures. So those are enclosures that separate the surrounding lake from the inside of the experimental unit. And we inoculated each mesocosm with with a community of fish, zooplankton, phytoplankton, and microbes. Then we dosed each mesocosm with a different concentration of microplastics, and the microplastics we chose to use were polyethylene, polypropylene, and polyethylene terephthalate with some chemical additives. The goals of our project were to look at the effects of microplastics to the freshwater community, and also to investigate the fate of microplastics throughout the food web and the water column. And I don't have results to share from this project just yet, but if you're interested, I linked the project website so you can follow along. And finally, I wanted to highlight one of the plastic diversion projects currently happening in the Great Lakes. The organization is called the Great Lakes Plastic Cleanup, and they currently have 26 trash capture devices installed in some of the marinas around the Great Lakes, including a sea bin in Lake Superior. So they use two types of trash capture devices. The left one is called the Lida trap, and the one on the right is called a sea bin. And the Lida trap sits inside storm drains and kind of passively captures garbage, including microplastics, from stormwater runoff before it goes down into the lake. These can be very effective at diverting plastics from the lake, and they don't require too much maintenance. They just need to be cleaned out every week or so. The sea bin on the right uses a more active strategy, and it actually pumps water through the mesh so it can filter out a lot of water very effectively. But it requires constant power and needs to be cleaned out more frequently. Okay, here are some of the findings from the Great Lakes Plastic Cleanup in 2021. They didn't have any data released for 2022 when I was making the presentation. But anyways, their trash capture devices diverted 130 pieces of plastic per device per day, which is really an amazing amount of plastic in the long term. And the majority of that was small foam pieces, small fragments, and small pellets, so a lot of microplastics. And there was a comparatively small amount of cigarette butts that they captured in their devices but although cigarette butts tend to be one of the most commonly found pieces of plastic pollution in stormwater runoff. Okay, with that, I would like to thank you all for being here and watching me talk, and I'm happy to answer any questions.
Amazing. So I've got a question in the chat that we can start with. It had to do with the lint lovers, I think. So where does the garbage from the microplastic laundry filters go? Would it end up in a landfill and perhaps run off to water again eventually, maybe, or stuck in the landfill? And we're noticing the filters intercept the direct flow of microplastics to waterways, but sort of what then eventually is the fate of that with the filter? Could you respond to that?
Yeah. So eventually, okay, yeah. So the like the physical material that you pull out of the lint lover, you throw that in the garbage. So it does go to landfill. I mean, obviously in an ideal scenario, the landfill has 0% leakage of, anything into the environment, but we know that that's not really the case. But it does, trap the microplastics instead of adding them directly into the lake. It does trap a bigger proportion of the microplastics compared to just putting it in the lake.
Thank you. And folks, if you do want to ask a question, feel free to click on that reactions button and raise your hand, and then we also can you can unmute and ask that way. Oh, Lindsay, you jumped right on that. Lindsay, we'll take your question and then I'll get to Elizabeth's question in the chat. So Lindsay, go ahead.
Sure, thanks. Is my audio coming through, Rachel?
Yeah.
Yeah, great. Thank you, Kennedy. Great job. I agree. The visuals were all really helpful for seeing and trying to understand some of the complexities here. And I wanted to hear a little bit from you, Kennedy. What do you see as sort of the key trends and movement in this research space broadly? So what are some of the key questions that people are asking? So I'm a health scientist and I focus on human health and intersections of human health and ecosystem health. So I pay attention to the health sciences world of microplastics, but I wonder if broadly you can just give us a sense of where things are headed.
Yeah, that's such a huge question in a way, because the field of microplastics is still relatively new. When I started my PhD, like 5 years ago, it was still like really, really developing. And in the 5 years of my PhD has made massive strides in what research has been done. Because I've done most of my research on effects testing, the kind of direction of effects testing that I've seen is to look more at this like complexity of microplastics and recognizing that microplastics come in so many different shapes and sizes and have different chemical additives, and that there's no like one single effect that we can identify that microplastics has. It's more of like looking at the vast array of effects at different levels of biological organization and trying to understand how each of those key elements affect each other. So some of my colleagues are working on this like adverse outcome pathway development for microplastics. So that's trying to identify what the molecular events are that are happening in wildlife's, in their body, in their physiology when they get exposed to microplastics, and trying to link all of those to see what are the effects at the individual level, at the population level, and the community level. In terms of like what's out in the environment, there's also massive strides being made in looking at nanoplastics. So as I mentioned in my talk, like right now, a lot of the environmental samples, we're looking at microfibers, and you can get even smaller than microfibers down to like the nano level. So those particles are really, really, really difficult to isolate from environmental samples because there's so much other material going on in the biological sample already, like sand and like zooplankton exoskeletons and stuff. So they can be really hard to isolate. But I know there's a lot of like strides being made in nano materials to help identify how much nanoplastic is out in the environment, because we suspect that it could be really a lot.
Thanks for reflecting on that for us. That's interesting to hear about. Okay, so Elizabeth asked a question, and I think this came up in the chat when you were talking about the plastics in the fish themselves. How representative of the lakes are fish concentrations in bays?
Yeah, it's interesting. There is a trend in that people have documented, scientists have documented, where microplastic concentrations in fish increase with the concentrations in the water. So in like it's intuitive in areas with higher microplastic concentrations just in the water generally, the fish will also have higher concentrations of microplastics. But it's also true that the microplastics found in a fish's gut is just a snapshot in time. So it doesn't give you this sense of what it's been exposed to during its entire life. It just shows you what it ate maybe for breakfast that day or something, because some microplastics can get excreted. And we also know that some microplastics do accumulate. So it's kind of a complicated answer. And I would say they're definitely connected, but it's maybe not a one-to-one connection. Like it's not, super directly related, but it is really, it's complicated. Like with anything with microplastic pollution, my answer tends to be, it's complicated, which is not very satisfying, but it's the truth.
It's true with lots of things. Thanks for reflecting on that. I don't see any more questions in the chat. Would anyone like to ask a question in the chat or raise their hand? Great, Joni, go ahead.
That was just an absolutely fabulous presentation. Thank you so much, Kennedy. I live near Batchewana Bay. I work out of a land trust that is for the health of the watershed of Lake Superior. and I'm super interested in how to do something effective on Batchewana Bay. The Nature Conservancy of Canada is working on the project of acquiring the island, and there's just a huge opportunity to bring the community of the bay to understand this plastics world in the Great Lakes better. And you brought up the sea bin, and, you know, of course, I think you said the lint lover, that seems like a very practical thing for people to actually do, because everyone says, what can I do? But at the sea bin level, that seems like a very big project. Like that's a very, like that must be thousands. I haven't even had a chance to look it up, but I'm looking at your picture. Where would one sort of begin in that way, I guess? I don't know, maybe that's too big of a question.
Yeah, no, it's a great question. If you're looking at the level of a community, I think a great, like, sea bins, litter traps, and lint lovers are a great place to start. If you have funding through organizations like, I know in Toronto, I mean, so I'm more familiar with like the sea bin project in Toronto because that's where I did most of my research, but in Toronto, there were a lot of different stakeholders that were interested in participating in the sea bin project. So like the Port Authority in the Toronto Marina was interested in collecting the plastic from the marina. So they were able to kick in some money and purchase a sea bin. And I know that the litter traps, those ones are around $1,000. And you can purchase them through the litter trap. I think it's an Australian company. You can purchase it through their like sales representatives. They both also require some level of interaction. So the sea bins need to be cleaned out, I think, like every couple of days. So they are more of like a resource intensive way of going about it. Litter traps, I think, don't need to be cleaned out as often, and they're more of a passive sampler, so they can go a little bit longer without being cleaned out, but they do need to be cleaned out, I think, once a week. And as for the litter traps, there was a big community project led by one of the researchers in my lab that I just think is such a fantastic project. They worked with Georgian Bay Forever and were able to install lint lovers in like 10% of the community, I think. So they got volunteers from the community to sign up to put lint lovers in their washing machines, and they had the volunteers clean the lint lover filters every, I think, week, so once a week, and they were able to show like a significant impact on the wastewater treatment effluent microfiber concentration. So even just a small portion of the city having lint lovers made like a huge impact on how much microfibers were released. So I don't know, those are some of my ideas, but
That's fantastic. Can you give me the name of the organization on Georgian Bay again that led that incredible project?
yeah, so it was Georgian Bay Forever.
Okay.
And the scientist was Lisa Erdl, Erdle. She's released a paper about it, so you can check that out as well. Yeah, thanks.
Thank you so much.
No problem.
Thank you for that great question, Joni. I know we have folks attending from all sorts of sectors and folks who attend who also participate in those beach sweeps or organize them even and are trying to think about how to put this into action. That's great. We've got another question in the chat from Wen Shang. Any information about environmental microplastic contents before plastic was invented? If you want to unmute and elaborate on that, go ahead, or add something more to the chat.
So, yeah, I'm not sure that I fully get where the question is coming from, but I do know that in the sediment, you can actually look at a core of sediment and pinpoint like when microplastics became, or sorry, when plastic became super common, because there'll be more microplastic concentrations in the sediment. So maybe that. I don't know
Were any of the chemical additives that we now add to plastics, or any of those chemical additives being used for anything else prior to their application to plastics? Do you know?
I don't know. Sorry.
Yeah, that's fine. Just curious.
Here we go.
Oh, here. While we think of plastic as a 20th century material, natural plastics such as horn, tortoiseshell, amber, rubber, and shellac have been worked with since antiquity. Animal horns, malleable, when heated, were used for many purposes in products from medallions to cutlery.
Yeah.
So yeah, thinking of those materials again. Thanks for that elaboration.
Yeah. I'm not familiar with any research that has been done looking at that, but it is really interesting and a really like poignant idea, and people could be doing that research. Maybe I'm not familiar with it.
Yeah, I haven't heard of the term natural plastics before.
Yeah,
and
I
thinking of
know.
these materials. That's really interesting.
I know, like, okay, this might scare some of you, but you know, gum is made out of plastic, like chewing gum. It's made out of plastic. Sorry to be the bearer of that news. But I know that in history, people have chewed like tree resin. So it's like this, like it has the same like gummy consistency. So that's like one. Yeah.
Ooh, okay, great, thanks. Also a question here, if we think about generally the Great Lakes or freshwater, maybe more broadly, is a bit underrepresented when we think about research on the fate and effects of plastics compared to marine ecosystems. And one is that observation actually correct, and why maybe are marine ecosystems receiving more attention in this area than freshwater or Great Lakes ecosystems? Any thoughts on that?
Yeah, it definitely is true. I did when I started my PhD, it was like a huge discrepancy between marine and freshwater. It was like 80-20. So 80% of research doing marine and 20% doing freshwater. It's a little bit better now, but it's still true. And I think the reason why it happened was just because the term microplastic pollution was first coined in the marine sphere. So I think it just kind of like, when people started becoming interested in the idea of plastic pollution as an area of scientific research, it was focused on marine ecosystems because that's where it was first identified.
Thanks. We have another question about if you could reflect on or offer suggestions of how we think about the responsibility of industry or the responsibility of manufacturing in their use of production of microplastics. Like what role, what policy could be put in place to place that responsibility with the producers, if you have any thoughts on that.
Yeah, it's an interesting, it's an interesting area of thought, because, or of research and thought, because a lot of the solutions that, you know, people talk about are such individual level solutions. So like installing a washing machine filter on your own washing machine, that's a cost to you and resource intensive to you as a consumer. When you didn't produce the plastic, you just, you know, kind of are somewhat forced to use plastic in some scenarios. Like you can hardly go to a grocery store and not get something that's in single-use plastics. It's very difficult. So yeah, I do think a lot more of the responsibility should be put on the end of the producer. Not only to reduce how much single-use plastic is being made to begin with, but also more of responsibility to actually have that plastic be recycled and repurposed back into the system, you know, rather than just going to a landfill or going into the recycling, where it sometimes, you know, doesn't even get recycled. And part of that has to be also from policy to incentivize people or like industries to recover and reuse plastic. So right now it's a lot cheaper to just use manufactured plastic rather than to use recycled plastic, because you have to go through that recycling process. So if there can be policies to incentivize the use of recycled products, that is another way of just making it more likely that industries will actually do it.
Great, thanks for sharing those thoughts. Do you see any This is my own
think
question.
Joni
Do you
has her
see
hand up.
any, oh, thanks, Joni, go ahead.
Oh, just a quick question. The recycled plastics industry, I've heard that a huge amount of the plastics that go into recycling actually are not even recycled. Do you have any kind of a percentage idea on that?
Yeah, the like oversimplification statistic that people, talk about is that 9% of plastic is recycled. Part of that is because a lot of plastic gets shipped elsewhere to like developing nations, and they have to deal with it rather than us dealing with it. I think some of that is also because and again, I don't want to put this on us as individuals, but there is a role that we play in recycling. So you can't just, some people don't know that you can't just recycle anything that's plastic. Each municipality has regulations on what it can and cannot recycle. Like in Toronto, for example, you just can't recycle black plastic. It won't be recycled. So really looking into like what your municipality can actually handle is important. Yeah, and like cleaning your recyclables is really important. But yeah, it's true. A lot of plastic doesn't get recycled, and that's it's really a shame. I don't know.
Well, it's such a good consumer information that you've given us as well, because I think there are things like whether it's cigarette butts or chewing gum, we just don't think of them as a contribution to the plastics problem. And yeah, it kind of starts there as well as to like, what can I do? The consumer part. So thanks for your answer.
Thanks, Joni. We have time for another question if anything's itching at the back of anyone's brain there. Okay, I always get the consumer item I always feel conflicted about is tea bags, because I've heard they're made of plastic, but then they're full of organic material. So I want to put them in my compost bin, but then I know I'm putting plastic in the compost bin. So if I get loose leaf tea and use a steeper, then that resolves that problem. But yeah, again, these are actually larger systems that need to change. Do you see the future of like the bioplastic, this idea that we have compostable plastic, or as we were getting at these more natural materials that can get conserved the same way? Like, is that like, I love the idea of eventually going to the grocery store and just knowing the clamshell of blueberries, the plastic is made out of not oil materials or petroleum materials. Do you know what I mean? Is that even remotely, do you think, in our lifetime, or like, where's that research at, to the extent that you know?
Yeah. So again, it's not an area that I'm super familiar with, but it's I'm a bit conflicted about it, to be honest, because a lot of the bioplastics that I know of, even though they might be marketed as being compostable or biodegradable, they won't biodegrade in a landfill. So because they get compacted in, and there's such a lack of oxygen in the landfill, the product just can't biodegrade by itself. So the only scenario that I could see bioplastics being useful is if you could like compost them in your garden or in your backyard or something. And it might be that we get there. I don't know. Yeah.
Thanks for reflecting on that. Yeah, those extra pieces are important to think about. Joni?
I got a lot of questions. The whole consumer thing around clothing and material, just really, even when I just thought about the amount of stuff that we talk about getting recycled back into like jackets and different things, they're all containing little fibers of plastic. Yes. And so they're a huge contributor once you wash them in your washing machine. Just, do you have particular like sort of sources or way to, I just like to disseminate more information about that, and any good suggestions that you have?
Yeah, it's so tricky. There's like, I know there are big companies, or not big companies, there's companies that use I honestly kind of think this is an example of greenwashing, where companies will say that their textiles are made out of recycled products or recycled water bottles, but then in reality what that means is that you're taking a water bottle, making it into microfibers, and then as soon as you wash that, you're just releasing microfibers into the environment. So how beneficial is that really to the environment if you're just taking one form of plastic, making it into a more harmful form of plastic, and then having your consumer release that into the environment? It's really complicated. And what I would say is, as a consumer, just trying to be like really intentional about what brands you choose to purchase from. So fast fashion is a huge source of microfibers into the world and the environment. The brand like Shein, I don't know how to pronounce it, but they like produce so much synthetic clothing on a daily basis. It's just like hard for the mind to even like realize how much plastic they're actually creating, how much microfibers they're creating. And a lot of those clothings are made to not last a long time. So they're made to like disintegrate and break down after washing them a few times, because they want you to keep coming back and buying more stuff from them. So trying to, purchase products that are gonna last a long time. Maybe they're products that are made out of natural materials like cotton and linen and stuff, is a great idea. And purchasing secondhand, so going to thrift stores and stuff, is also great. I mean, you still find fast fashion brands there, but at least you're not giving your money directly to the fast fashion brands. But yeah, just I think being intentional it's hard, but I think that's how we have to do it on the individual level.
I think, speaking on behalf of everybody on this call today, one of the most impactful things you shared with us, Kennedy, is the question that we all ask is, what can I do? Everything around the climate change story, biodiversity loss, and everything seems so insurmountable, but you've brought a really big story to us in a way that breaks it down into what can we do. And so thank you for doing that. It's just been thank you so much for bringing this to us today.
I agree. Thanks, Joni. You concluded us really nicely there. You did my job for me. Well, that's great. I know we're at time here, folks. Thank you for being with us today. We do have Kennedy's contact information, and she had it posted there for a while. If you missed that though, just let me know and I can connect you. Otherwise, thank you so much. Enjoy the rest of your day, and we'll be in touch. Have a good one.
Thanks, everyone. Thanks, Rachel.
Thank you, Kennedy. This was awesome. Dr. Bucci, sorry.
Yeah.